Dear student, welcome to the next part of application of partial differentiation, that is unit number 3, engineering of mathematics 1. Okay, dear student, in this videos we will discuss maxima and minima of a function. Okay, in this video we will discuss maxima and minima of a function of f of x comma f of x comma y. Okay, now before we watching this video, please share this video and subscribe my YouTube channel. In this video we will discuss maxima and minima of a function f of x comma y. Dear student, first we see the working rule about the maxima and minima, how to find by step. Look at here, first step is only simple: find del a by del x and del a by del y and equate them to 0. It means that we have to give one function in terms of x and y, then we find firstly partial differentiation of f with respect to x and with respect to y. After all, equate them equals to 0, means we have to get some function in terms of x and y, then we say that is equals to 0. Okay, then next step, solve this about we have to give on two equation, we have to give it two equations, and then we solve these two equations by simultaneous method. Then we will get x is equals to something value and y is equals to something value, which is known as a stationary point. Okay, after that, in step number 3 you have to find calculate r. Okay, what is r? R is the del square f upon del x square. It means that second partial derivative of f with respect to x. Okay, and next find find s is equals to del square f upon del x into del y, which is equals to, we can say that del upon del x in bracket del f upon del y. Okay, it means that second partial derivative of f with respect to x and y respectively. And third step is find t. What is t? T is the second partial differentiation of f with respect to y. Okay, find this three steps, be carefully, because of these are very important steps. Okay, in the last step you have to find and check the sum conditions. We have to first find r into 2. It means that we have to already find r and s and t. Here in step number 4 there is sub 4 steps. In the first step, r into t minus a square, and then this time is greater than equals to 0, and also r is less than equals to 0, then you can say that f of x comma y has a maximum value. Okay, then second case, check second case, r into t minus a square is greater than 0 and r is also greater than 0, then you can say that your function has a minimum value. Okay, look at this, these two conditions are very important. Your r is less than 0, then function has maximum value, and your r is greater than 0, then you can say that your function is a minimum value. Okay, in the next step, in next sub case, r into t minus a square is less than 0, then your function is neither maximum or neither minimum. In last step, r into t minus a square is equals to 0, then there is no any conclusion about your function. Okay, because look at this sub 4 cases is very important, because in we will discuss after questions, we will get the some result about your function, because we have to find maximum and minimum value of a given function, and we have to check these 4 conditions. Okay, now see the one more example about this concept. Okay, dear student, in this question we have to discuss the maximum and minimum of a f of x comma y is equals to x square plus y square plus 6x plus 12. Okay, look at this these steps very carefully. Again, once again, you have to first find del f and del f upon del x and del f upon del y. Okay, now how to find maximum and minimum function. Okay, right, first given that these are very important steps. What is given? You have to give one f of x comma y is equals to x square plus y square plus 6x plus 12. Okay, now first step, Step number 1, find first step is del f upon del x. It means that partial differentiation of partial differentiation of f with respect to x. What we get? We get 2x plus 6 is equal, okay, 6. Okay, and second, to find del f upon del y, what we get? We get 2y. Okay, that's very simple step. Then second step, move to the second step. In the second step we have to equate del f upon del x is equals to 0. Therefore del f upon del x is equals to 0, which is implies that 2x plus 6 is equals to 0. And similarly del f upon del y is equals to 0, which is implies that what we get? 2y is equals to 0. And in the second step we have to equate del f upon del x is equals to 0 and del f upon del y is equals to 0. Then solving these two equations, this is equation number 1 and this is equation number 2. Solving these two equations by simultaneous method, we will get x and y. Now from equation number 1, 2x plus 6 is equals to 0. We can find x easily. What we get? X is equals to 6 upon 2. It means that x is equals to 3. And similarly from equation number 2, 2y is equals to 0. It means that y is equals to 0. Therefore we get x is equals to 3 and y is equals to 0, which is known as stationary point of a given function x comma y. Therefore you can say, therefore x comma y is equals to 3 comma 0 is called stationary point. Now move to the next step. What is the next step? Next step, find r. What is r? R is the second partial derivative of f with respect to x. Okay, now how to find? How to first find del upon del x in bracket del f upon del x is equals to del upon del x as it is. What is value of this? We have to get value of del f upon del x is a 2x upon 6. Then find once again differentiation of this term with respect to x is, we get only 2. Okay, it means that r is equals to 2. We can say directly, therefore r is equals to 2. Then next, find s. What is s? S is the second partial differentiation of f with respect to x and y both. So I am right here simply del upon del x in bracket del f upon del y. Okay, del upon del x as it is. What is value of del f upon del y? Del f upon del y is 2y. Okay, in the question number 2 here 2y. So what is meaning of this term? Meaning of this term is partial differentiation of f. This term, it means 2y with respect to x, we get 0. It means that therefore s is equals to 0. Then next step, find t. What is t? T is the second partial differentiation of f with respect to y square. It means that del upon del y in bracket del f upon del y. Okay, del upon del y as it is. What is meaning of del f upon del y? In the equation number 2 we get 2y. It means that find this term, find partial derivative of this term with respect to y. It means that we get 2. Therefore t is equals to 2. Okay, in the step number 4 we find r into t minus s square. Okay, where r is 2, t is again 2. Okay, therefore 2 into 2 minus s, s is a 0, so bracket whole square. 2 into 2 is 4 minus 0 is 0. Okay, which is equals to 4, and 4 is greater than equals to 0. And r is also, sorry, what is r? R is equals to, r is also greater than equals to 2. Okay, these are very important things. R into t minus s square is greater than 0, and only r is also greater than equals to. Therefore f of x comma y has maximum value. Okay, Therefore f of x comma y has maximum value. Therefore what is the maximum value of this function? Okay, put what is given f of x comma y. F of x comma y is given x square plus y square plus 6x plus 12. Okay, therefore f of x is 3 and y is 0. Put this value in equation number, yeah, is in your given equation. What is 3? 3 x is a 3 whole square plus y is 0, 0 bracket square plus 6 into 3 plus 12. 3 the square is 9 plus 0 square is 0 plus 6 3 is 18 plus 12, which is equals to, okay, 12 plus 18 is 30, 30 plus 9 is a 39. It means that maximum value of this given function is 39. Okay, thank you students.